Okay, next we move on to lipids. The components of lipids are majority is contributed by triglycerides, which is 95%. The second component of lipid is phospholipid. For example, is lecithin, which is found from soya. Third is sphingolipids. For example, sphingomyelin, ceramide, cerebrocytes, gangliosides, which are commonly found in nervous system. Next is sterol, for example, is cholesterol, and last is waxes. Okay, first we will look at phospholipids. So phospholipids are the modification of triacylglycerols, where the non-lipid component is phosphate groups. Okay, like in LU2 we have phosphoprotein, so it has phosphate group. Okay, in the protein component, similarly, phospholipid has phosphate in the lipid. Okay, so it's the non-lipid component is phosphate. The advantage of phospholipids, it can prevent crystallization at ambient temperature due to its polar in characteristic. Okay, so when it's polar, it will prevent crystallization, especially when applied to food products. So all fat and oil containing food will have phospholipid in them, and the lowest amount of phospholipid are present in pure animal fats, such as lard and beef tallow. So high phospholipid are found in plant origin. So in some vegetable oil, for example, cottonseed, corn, soybean oil, the phospholipid present at rather low percentage, which is in the range of 2 to 3. In fish, crustacea, mollusk, those with shell will have about 0.7% phospholipid in the muscle tissue. So most phospholipid are obtained, high phospholipid are obtained from soybean oil, and they are used as emulsifier in certain foods, for example chocolate, which enable mixing of immiscible oil and water component, so it acts as emulsifier. So soybean phospholipid contain about 35% lecithin, and the rest are cephalin, and the lecithin are the one that has both hydrophilic and hydrophobic character. So if you look at this chocolate packaging, okay, you will see one of the ingredient is lecithin, okay, normally from soybean origin, which are used to act as emulsifier to enable oil and water to mix. Okay, so you can see here, okay, soy lecithin. Okay, another packaging of chocolate. Okay, you can see here soy lecithin. Okay, this slide shows the structure of major phospholipid found in plant Okay, so lecithin and cephalin. Lecithin, which is actually the chemical name is phosphatidylcholine, and for cephalin, the chemical name is phosphatidylethanol-amine. Besides lecithin and cephalin, there are also phosphatidylserine and phosphoinositides content as well. So the next type, next component of lipid is sterol. Sterol are the derivatives of steroids, and these are example of non-polar lipids. Okay, so if phospholipid is polar lipid, sterol is non-polar lipid, and they have 3 6 carbon ring and 5 carbon ring attached to an aliphatic chain. So this is the general structure of sterol. You see 6 carbon ring with 5 carbon ring, and they are attached to aliphatic chain. So sterol, of course, will have OH group attached to carbon 3 of a ring, and if they are found in plant, it is called phytosterol, and if the sterol are found from animal origin, so we call them zoosterol. So easy to remember. Okay, zoo normally associate with animal. So the animal lipids, the major sterols are cholesterol. Okay. In plant lipid, the major sterol are beta cytosterol and stigmasterol. Dietary phytosterol will decrease the cholesterol absorption in our intestine. Okay, and therefore these phytosterol are added to food to reduce blood cholesterol level. So normally cholesterol is associated with as bad lipid, okay, compared to plant origin. So that's why dietary phytosterol is added instead, in order to decrease the cholesterol absorption. So this is the general structure of sterol. So you see there are 3 6 carbon ring here attached to 5 carbon ring, and they are attached to a aliphatic chain. So this is steroid and this is cholesterol. These are the plant sterol. Okay, stigmasterol, beta-cytosterol, camptosterol, and brassicasterol. The next component of lipid is wax, and they are classified according to the origin, like sterol also from animal, it's called beeswax. From plant origin, it's called carnauba wax, and if from mineral, it's called petroleum wax. Wax are found on the surface of plant and also animal tissue in order to repel water and also prevent the loss of water, okay, from the structure, from the tissue structure. And wax are commonly added to the surface of fruits in order to slow down the dehydration of the fruits, especially during storage for export purposes. So therefore the fruit will last longer. Okay, next we'll look at physical properties of fatty acids, saturated versus unsaturated. So here we look at saturated stearic acid having 18 carbon in its chain. The melting point for this stearic acid is 73 degrees Celsius. However, if we compare with another fatty acid, specifically unsaturated fatty acid, in this case here is oleic acid, having the same number of carbon, which is also 18, but with the presence of one double bond, the melting point decreases drastically to only 5.5 degrees Celsius. So here we can conclude that if the double bond increase, the melting point will decrease. So as there are more double bond, the melting point become lower. Okay, if we want to compare between saturated acid, fatty acid, the longer the chain, the higher the melting point would be. So here is another two unsaturated fatty acid. So here linoleic acid have 2 double bond, linolenic acid have 3 double bond. Look at the melting point value. Okay, as the double bond increase in number, the melting point will also on the other hand will decrease. So here we'll have negative 13 degrees Celsius. 3 double bond will reduce further to negative 24 degrees Celsius. And that is why if there are more double bond present in fatty acid, it is reducing in terms of its oxidative and thermal stability. So it becomes more more unstable. Okay, as the double bond increases, and that is why fatty acid with high number of double bond is susceptible to lipid oxidation due to its low stability towards oxygen and also heat. So this is comparison of the monosaccharide, linoleic, linolenic, and saturated fatty acid content in different origin. Okay, so if you see here, high oleic sunflower will have highest percentage content of monosaccharide compared to saturated fatty acid. Okay, on the other hand, coconut will have the highest content of saturated fatty acid compared to monosaccharide. And also unsaturated, linolenic and linolenic. Okay, so coconut oil therefore is oxidatively and thermally stable compared to safflower, which has high percentage of linolenic and linoleic double bond unsaturated fatty acid. Okay, so high percentage of double bond fatty acid will susceptible to lipid oxidation and also thermal degradation. So next we'll look at the function of fat in food nutritional role. Okay, why fat is important in our diet. Okay, so if you want to go for diet, you cannot eliminate fat totally from your diet intake. So you need also fat in your diet, but in controlled amount. Why is that so? Because it's the only source of essential fatty acid. Similar like protein, you need essential fatty acid which cannot be produced by your body. So you can only get it from your diet, okay, the food you take. So example of essential fatty acids are linoleic and linolenic. Another purpose of fat in our diet is as carrier for fat soluble vitamin. So vitamin A, D, E and K also important for your body. So in order for these A, D, E, K vitamins to be absorbed by your body, you need the carrier for it, and which is fat. So without fat, how your body can absorb these 4 vitamins? So you need fat. And of course, the third reason of fat is source of energy. So it supply 9 kilocalorie for every gram of food versus only about half 4 kilocalorie per gram if you take carbohydrate or protein. Next, we will look at the functions of fat in food in terms of its appearance and also texture. Now, first we look at the appearance. So solid fat will look opaque compared to liquid oil, which is clear. This is because light passing through solid fat is scattered by the fat crystal present in the solid fat, which make them look opaque. Whole milk, on the other hand, which has 4% of fat content, will appear whiter compared to skim milk, which contain only less than 0.1% fat, due to the fat globule in the whole milk that scatter light strongly, unlike skim milk, which only have casein micelle, scatter light more weakly. In terms of texture, shortening fats that are used to provide functional properties, especially for baked products, for example cakes, breads, pastry, and example of functional properties given by shortening, for example tenderness, texture, mouthfeel, incorporation of air, so that it look more fluffy, okay, and at the same time extending the shelf life of the baked products. Shortening also able to prevent interaction between protein or starch molecule, which serve to tenderize the product. And shortening also have the ability to form 3-dimension fat crystal network, which provide the textural characteristic of the food products. Next, we look at flavor function. The even carbon numbered and short chain fatty acid in the range of carbon 14 to carbon 12 will impart cheese flavor to food product. And hydrolysis of hydroxy fatty acid, which will form lactone, provide coconut and peach like flavor to food product, and it's not actually directly from coconut or peach. Next function is mouthfeel. Of course, liquid oil will give oily mouthfeel when eaten, and fat crystal will give grainy mouthfeel if they are large, but if they are small in size, it is more smooth in terms of texture. The melting of fat crystal in the mouth will cause a cooling sensation to the people eating the food product